Hey, Alexei, how's it going?
Hey, good.
Good.
Friday.
Oh yeah, it's Friday and
Yep, already.
it's warm, right? Because it's
Because it's summer, yes.
yeah, not fair. Yeah, we are cold and rainy and not Friday. This is the worst.
All right.
My,
Because when it rains in Russia, the saying goes that the weather is whispering, borrow but drink.
borrow my drink.
Borrow money but drink. You have to drink anyway. That's what the weather is whispering. But it's not Friday, so not just
Not
yet.
Friday. Yeah, yeah. I grew up in Arizona where it didn't rain as much, and now I live in Oregon where it does rain a lot, and but it's kind of nice. It does whisper. It says like today you stay inside, today you go outside. And Arizona is always stay inside because it's too hot.
Well,
um,
I remember going to Austin in summer with
mhm.
temperature above 100 Fahrenheit, and it was nice outside. I was like catching warmth because it came from winter, Australian winter, but still winter.
It's the winter. Yeah. Is it humid?
Where I live now,
No.
in
There you go.
Sydney, yes.
Okay. I've
Well,
only been to Sydney.
It's it's humid about 10 kilometers from the beach, or maybe less, and then it's dry.
That's right. You're, you're in Canberra or you're in
Canberra.
Canberra? Yeah. I visited Australia when I was in fifth grade, and I went to school there for a little bit, a few weeks, and this was in Sydney.
Hmm. Close to the beach.
Yeah, Darling Point, I guess, close to the harbor.
Oh, okay.
But so, so I
Well,
think Yulun is on holiday. Anish said he wanted to try to make this one, but I don't see him. Um, I only had a few things. I wanted to. Um, I wanted. So I took a look at. I took a look at your branch, and all right, now I see some other people coming in. So I took a look at your branch, Alexi, and you do have certificate blobs exported through the common TSM interface. And I was looking, and I don't know if you saw this. I added you to the thread where they,
yeah, I'm reading it
yeah,
and
the Rust
enjoying.
thread. So, so I feel like, I mean, so Lucas had this plan to do CMA. I think the kernel should still do it, but it was going to set up this conflict between, okay, you can authenticate through CMA or you can authenticate through the TSM. Um, I think I'm just going to push on this idea that if that ever comes around, that it just shows up as another TSM driver. So you can connect the platform TSM or you can connect the kernel TSM. And the kernel TSM can't mitigate all the same problems that the platform TSM can, but it can do something. It can tell you the identity of the device. It can set up an SPDM session. Maybe on some platforms it can even set up IDE, but that's about it. That's okay. That's not nothing. Um, but if we put the if we put the stake in the ground that that SPDM native SPDM will come through the TS will just be another TSM driver, then we can just go ahead and create an ABI the way you have it, or similar to the at least attach it off the TSM stuff um, to dump certificates, dump measurements, all that kind of thing. Um, I I do agree with Jason that if we're going to put some of the stuff in Netlink, like selecting, like adding a nonce to recollect measurements and that kind of thing, and all these kind of certificate, like selecting the certificate, all these kind of different transactional things that we that all should probably be a netlink. And if any of it netlink, if any of it is a netlink, then maybe all of it can be. I'm not opposed to like Lucas or you trying to also do the SysFS thing, but um, it's pretty clear that we're gonna need netlink for some of this. And so I think I was gonna see if I can just take what Lucas has for netlink and use that to dump the certificates that that you collect at connect time, and then use that as a model so everybody else that comes after and says, yeah, TDX, CCA, when you get your certificates, just put them in the same place, put them in this common place, and we'll dump them over this netlink interface, and off we go. And then we can do the same for measurements as well. Because this has been kind of the logjam of like, how do we get this stuff out of here? Like, oh, somebody will figure it out. I think we just need to come up, put out a proposal and let the community chew on it instead of trying to dance around this a bit more. So
we will use netlink.
Use netlink. Yeah, it's kind of overkill for just dumping these static certificate blobs, but it's not overkill for anything that's transactional, like give me this data, like recollect this data with this nonce, or configure the device to pick a certificate slot, or even provision a new certificate slot. Those kind of tooling things, we'll probably just put that all into a netlink interface.
Okay. How often do people use netlink for stuff like this?
Um,
it's like a socket, right?
It's like a socket. I mean, I think the biggest example is the ETH tool, ETH tool, like the Ethernet device configuration tool. That's a big netlink user. But I mean, of course, the networking people love it for configuring networking stuff. So it's, but yeah, I think if we're basically gonna be building a PCI auth tool to do a lot of the stuff. So we kind of model it with the same way ETH tool works, and off we go. Oh, there's a new tool. We were just talking about the how to kind of break the community logjam and like how do we get SPDM collateral out of all these things, and just noticing that Alexi has the TSM blobs, the certificates as a TSM blob, like a generic kind of part of the TSM core. I think my proposal is we just kind of run with that idea, which would mean that if Lucas comes around with native CMA support, he just adds a SPDM driver, TSM driver that puts the blobs in the same place.
But the same thing is also coming via netlink, isn't it?
Right. No. So that's what I'm saying is that like we wouldn't. So I would. The idea of putting them in the TSM core is what we take. We'd probably skip the SysFS altogether and just keep everything in netlink. If somebody really wants SysFS, they can always add it. But like, there's nothing stopping us from, if we're going to have a blob dumping interface over netlink, might as well put certificates there, and just go with that and have a tool to do this.
Okay.
So it's just kind of like a break the arbitrary long jab by just putting something out there instead of kind of dancing around it and waiting a bit. I mean, I also think like Lucas hasn't had really had time to push this stuff. Even the rest of SPDM library is kind of waiting for somebody else to have a user. But that comes back to CCA. Why does CCA need the VMM to tell it which public key to use? I know we need like TDX and TAO. They have the ability to select which device slot to use. But why do we need to tell because like the reason I'm asking is because the Alistair's he's like, oh hey, can we get these precursor
Yeah, we don't have the
Private ISO.
certificate parser in the firmware.
Okay.
So that entire code is in the host. So basically, the host will parse everything, pick the key, and then tell the firmware which key to use for all the thing.
Okay, I mean, but even the tiny CCP firmware has a certificate parser.
I can
It's
double
for each.
check. I mean, I can
Okay.
see if that is, uh, instead of us parsing it, can we just hint it by the slot number and then the firmware parse, right? If I understand correctly, that's what other firmwares are doing, right?
That's what other firmware is doing. It's not. I mean,
Yeah.
it's really not in the way. It's just it's a complexity that's 100% on in ARM code, so it doesn't really bother anything else. But it's just one of those things that sticks out as that's different.
Yeah, yeah, yeah. Got that. I can double check. Yeah, that should.
Um, but yeah, so 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 that was one piece. Like, so I think that's the plan for at least a straw man proposal for how we can finally get some of the basic blobs out of this interface. The other thing that's a question that I have before setting out kind of this next round of the guest side stuff is, well, so the other part of that thread where Jason was talking about, we're talking about what does it mean for a device to be authenticated? And the SPDM proposal was, hey, like we're actually gonna put a key on the key ring, and the kernel will actually do like certificate validation for the device and all this kind of stuff. Like, and it's not clear that we need any of that. That all of this can be done from user space. But in order for that to work, it means that user space always has a chance to validate a device. The rough plan we talked about, I'm making a formal patch for it. For the rough plan that kind of in that we months ago thread with Jason was, we should probably have a mode where, like, especially for a confidential VM kernel, um, where you opt out of any auto probing, so that if when a module arrives, it doesn't probe existing devices. When a device arrives, it doesn't attach to existing drivers without user space saying yes, go ahead. Um, so I think we're so right now that my rough idea there, and I'm still playing with it, is the simplest thing to do is to make that policy based on whether the module is a driver or not, or whether the driver is in a module or not, because that gives you a control point to say, yeah, if you build the driver into your kernel, you don't get a chance to say no to attaching. It'll attach whenever. And if you do as a module, then UDEV system
There are a
D.
couple of ways
Yeah.
to say kernel not to attach driver. I think haven't tried them. One is init call override, where you can disable init call of your driver if it's built in.
You can disable the init call of your driver, but that's also that is it's not like a global policy, right? I mean, we're going to end up with these monster command lines.
True. There is an option.
But it's true. That is an option. Yeah. I mean, this option isn't perfect. Also because there are some subsystems that like even that depend on the driver the device attaching to a driver immediately, and not having to wait for user space to take an action on it. So I think it is going to be messy, and I do think that it'll be a policy that needs to be modified over time. You might need to say, okay, some modules are trusted no matter what. You can always auto attach, and that's probably for subsystems where the kernel is creating the device object. So like PCI would not auto attach, but like any devices that a PCI driver creates might auto attach. So, something like this. But the piece that's missing for me is like it feels like the last mile of saying the guest side would be ready is our agreement on what we need to do for the DMA flags, like the DMA attach. I think we all agree on the force DMA. Is it force DMA unencrypted? Is one place that if the device is accepted, you don't need to force it unencrypted. But then we had this long debate on Discord about fizz to DMA and whether what AMD needs is kind of different than what everybody else needs. Was the result of that, Alexi, that are you on board with this idea that goes into a, like, you basically do that select to say, hey, my architecture has x86 has its own fizz DMA implementation, and when the guest is SNP, then you'll do the AMD thing, but otherwise Intel will not.
I'm still kind of struggling. So your SME mask doesn't have CBIT for encrypted memory.
It has a bit for saying it's shared. It's kind of like ARM in that way. Not exactly the same because it's not the.
And you want this bit to be in DMA when you do shared access.
That bit will be there when we do shared access. Yes.
So DMA handle will get the bit.
Actually, no. The DMA handle will never get any bits because that is handled by the MMU. So if it's t equals 0, when that traverses at least my understanding, I might be wrong. When it traverses the the host bridge, and then the bit gets added, the shared bit gets added.
So when you get to the point when you have IOMMU in the guest, you will have to decide what kind of DMA handle you give to the device. No, that will be guest address. So it won't have CBIT either. So there is no way you will have CBIT in DMA handle, right?
Yes. Yeah. You're saying like we're gonna have a problem when we actually have a VIA virtual IMU in the guest?
No, you will not have a problem because you don't use CBIT.
We don't use CBIT. We don't use CBIT in DMA, is my understanding.
So that's what I want. So in this way, we are the same, Intel and AMD.
No, I think the difference is the DMA encrypted and the DMA unencrypted functions will never do any SME mask game. So SME mask is always 0, whether it is encrypted or unencrypted. Is that the way to look at this, Dan?
I think that sounds more what
Now the complication is with AMD that needs the CBIT when MMIO is on, and that doesn't need the CBIT when TIO is on.
We only need CBIT on AMD with MemEncrypt when we don't enforce IOMMU. And the default option, we do enforce IOMMU. We don't need CBIT.
What I'm trying to get to is let us stick to DMA direct, right? If you are using DMA direct, if mem encrypt, you need CBIT on in the DMA handle. If I am using DMA direct but in using TIO in the guest, you don't need CBIT on because there's an IOMMU in the host. So ideally, I think what we should look at is AMD overloading these functions from the generic and then doing all these if conditions around, if I am TIO, if I am non-TIO with MMU, with IMU, all those conditions you can handle in ARC specific physics to DMA, right?
I mean, I think so, right? Like, I guess that's a question to Alexi. Like, it's yeah, like so the question is, I mean, I could send you a patch of what I think it needs to be for TDX because because I think the same patch would have the same problem as it does with CCA, and CCA does or ARM64 doesn't is not one of the arcs that has the what is it arc has this DMA.
Yes, we don't have that, but
Okay.
we do have this problem that Alexei was trying to find out by asking the C bit. We do have the problem that the DMA handle needs to be really large. So I was actually kind of figuring out, and I think there is some assumption somewhere around in the spec that any device that is doing that supporting TDISP would be capable of 64-bit DMA, and like for example, our T equal to 0 DMA handle is really large because it needs that top bit set. And if your DMA mask is, if the device cannot handle such a large DMA address, then basically we can't support that device. So that restriction exists.
Yeah, but like yeah, but the it basically means like yes, I would kind of assume that a TDIS device probably has the address capability, but if you're trying to do shared, then you're probably trying to support devices that aren't TDIS, and then yeah, you're kind of in a problem.
Yeah.
Um, yeah, but
There
go
are a
ahead.
few questions around that when I was trying to get this sorted out. Do we expect to use SWIO for trusted device?
You mean to bounce buffer private back or
Private.
to
Yeah. Like the DMA
like
mask.
if you wanted to access shared, but the device couldn't access, but the
No,
TDIS
no,
device
that's what
couldn't.
no, not for the shared. The device DMA mask is so small that it is not able to address all the private memory. Do we foresee such a use scenario ever coming up, or do we wait for such a device to appear?
I think it's weight. It's kind
Okay,
of a
that's all. Yeah.
like whenever waste an option, I always oh yeah, well, wait, that's a problem.
Okay, okay.
But
Yeah,
but I
because
think was it Robin that was saying like yeah, hopefully a lot of these devices I think are TDIS devices. The TDIS things these are like massive data center accelerator things. They're usually not like USB controllers and things. At least
yeah,
not yet.
yeah, yeah. Okay.
One class devices which don't have 64-bit DMA is AMD GPUs used in all these desktops and laptops. They do like 40-bit or 46-bit, not even like 51. But probably proper stuff like MI400 can do better. Haven't tried that. And that would be TDISP eventually, maybe.
So Alex, if I can understand you better, AMD GPUs are TDISP capable but 48-bit DMA.
No. Like AMD GPU in my laptop is not
Oh,
TDISP
okay.
capable, and its
Okay.
DMA mask is like 46.
Okay. Okay.
And if I put some old GPU in modern machine and wanted to do pass through in an old way, non-trusted, then probably would be, well, I don't have to have CBit in DMA handle, so
Yeah, if you that's
I
what I
can
think the
still
problem
use
is
all the
only yeah,
yeah.
the problem is only with ARM, I guess. We can't get that device in the shared mode or untrusted mode. But then I can also make sure that my guest IPA limit, whatever the maximum value for the guest real address is 47. So like the 48, you can't go beyond 48 bit for the guest IPA limit, 48 bit including the top bit which I'm using for shared private kind of hinting, right? So there is a workaround for that. What I'm trying to get is 48 is still big enough for to make it work because we may not have we may not have a guest which requires such large amount of RAM. Uh, yeah, so we can still get everything working, I guess.
Oh, your shared bit is like is bit 48 or something like that, or 52 or something.
Yes, it's not a fixed bit. So we kind of
Okay.
so we have this concept called IPA limit, which is intermediate physical address or like guest real address, right? So we can change that. So if it is a 48-bit IPA, I steal the 48th bit for hinting. So the guest IPA becomes 47 and
Okay.
RAM can be anywhere below 47. Like it's fine. Did I make sense?
Yeah. Yeah.
Yeah.
So, Anish, this issue is only most likely with legacy devices if there are any that are assigned to realms. Is that right?
Yeah, that's
Only
true.
for the,
That's true. That's true.
yeah. What's the probability like you end up having a confidential VM having with legacy devices?
Exactly. And the way to get everything working, if such a thing is needed, is probably to have stage one IOMMU. So the problem goes away, right? Like we can put them in the
Correct.
stage one. Yeah.
But earlier discussions was like, I mean, the way ARM SMMU is designed, like they have separate instances for confidential VM and, I mean, for T equal to 1 and T equal to 0, they go to
Correct.
different instances of
Correct.
SMMU.
Correct.
The earlier plan is that at Realms, we will not use stage 1 for non-secure. We would just have stage 1 supported only for the
Yes.
trusted
Yes.
devices.
Yes. Yes. Yes.
So,
Yeah. If such a thing is needed, if you want to accommodate such a device, we should have looked at adding stage one for non-secure. Yeah. I
yeah,
mean, you brought a good point. Like, if you ever need to support such device, what do we do? Yeah. I get that.
yeah, I think maybe it can be deferred.
Yeah.
Uh, on this guest request thing where you want to do large blobs, I mean, and especially, yeah, I think when we're getting into measurements and transcripts, like these things can be megabytes. That's what even Lucas was saying on the native SPDM thing. So I can see this being like a multi. So I agree with you. Yeah, it needs to support
Yeah.
multiple requests. But does are we all going to solve that problem separately? Like, does KVM understand? I guess, like, is it going to be something like the guest is going to be making a request, is going all the way back out to all the way to the host, partial completion all the way back to the guest. Guest is going to see if partial, send another one all the way back out. It's going to That's what you're expecting, or is it going to be something like, yeah, that's probably the only way it could work is.
Yeah.
Okay.
So if I didn't consume from a guest interface point of view, if I didn't consume the entire input buffer, the actual amount consumed from the input buffer becomes the return value of the function, the residue that we have as of now. And from the response point of view, if I didn't consume the full response buffer, that is, if I'm partially filling the response buffer, the actual size I filled becomes the return value in the pointer, right, that we are passing to that. Makes sense.
Yeah, yeah, but yeah, it's early. Yeah, we can still change that.
Yeah.
Um, yeah, I mean, so Lexi, that's what you're using now to stop autoprobe because the the biggest, well, I mean, the challenge I think is that if we, because I also want this policy of drivers don't auto attach, also for ATS, because with CXL and other kind of like, and there's been cases where people have said like, oh hey, this device has a problem, you probably shouldn't use ATS with this thing, where you might want to have the opportunity to say, yeah, don't either disable ATS or before the driver attaches, or don't turn on ATS early, these kind of things. So there's this thread.
What's ATS in this context?
ATS is address translation services. This is like bare metal.
Okay, why do you want special case for it? Why did you bring it up?
I brought it up because it's another use case for user space wants to have policy before the device starts doing bad things. So basically, this policy would not only just be for confidential VMs, but it might also be used for the bare metal case where you say, I don't want to trust ATS devices by default. Like right now, we trust them if ACPI says that they are an internal device, which means that they could be allowed to do to start doing operations as soon as they're enumerated, because we turn on ATS pretty early. At least on Intel we do. I think ARM you don't turn it on so early. But yeah, I think different RMU drivers do different things with ATS. So, but that's a little bit beside the point. But it is. I think it's going to be a bit of a debate. I think upstream about how do we, in general, make sure that user space always has a chance to say yes or no to a device before the driver attaches.
So this ATS problem is not entirely completely linked to today's bits, just similar kind of stuff.
It's not completely linked. It's similar, but it's the same kind of flavor of, oh hey, you should not attach to you should not start sending DMA until I say it's okay. And in that way, it's just kind of the same problem where we don't do DMA from these devices until we accept them. And then we trust them. And then we trust them for the rest of their lives.
Dan, why can't the user space unbind it? Like even if some auto probe happens and the device gets attached to a driver, it would never be in T=1 state. Why can't the user space like unbind whatever driver that gets attached during the boot time, and then it can transition into TDISP run state, do all the validation attestations, and at the end, it can enable DMA mappings.
That is also true. That you could have a mode that T=0 traffic is always okay.
That's what we do right now. I think the question is, what do we do with CMA outside TDISP, right? We want the device to be active or enable DMA after the device is authenticated on a CMA workflow, right? So I think the idea is to kind of consolidate all these things into kind of, can we say we have a mechanism to prevent driver being active for CMA because CMA wants the device to be authenticated, for ATS because we don't trust the ATS and we want to prevent ATS until somebody go and make sure it is okay to do ATS, and for TDISP until we transition the device to T=1. I think at a very high level, all these requirements are same, where we want to deny DMA from these devices, isn't it?
It is the same, but you are right that like there is built-in self-protection that we don't have in the that's really different. Like between CMA and ATS, those can do damage right away as soon as the driver attaches. I have to think about how to unify that policy, because I think we needed it also for
so it's also possible that then like there are cases like where device need to come up in the T=0 mode, and it has to set up some configurations, has to do some DMAs like loading some firmwares into the GPUs initially. After that, then it gets ready for the TDISP support. Like, okay, I mean, some initial setup need to be done and it needs DMA. after all of that, when the GPU is ready, that's when user space can start transitioning it into TDISP run state, like locking, validating, all of that. Then follows the run state.
Yeah.
So
But, yeah. But that is the difference. It's not like this policy says you can't attach it. It just says it doesn't attach by default, and you have to take an action. And so part of this is supporting this model of, hey, if the device needs to be configured before it's locked, there's kind of no point in so right now the plan is for devices that need to have some configuration done before they can be locked, is to have multiple drivers. Like have a setup driver that you load, put it in your configuration, unload it, lock accept, and then load the real thing. And so part of having this policy of like don't attach right away is because you don't know whether you're ready.
okay, I see. I see. It's just an option to disable auto probing for the devices that need.
So yes, but also yeah, but you gave me some food for thought of like it might be overkill in the default case where you're happy. Like I mean, right now all the computational VMs in the world right now are happy with auto probe with t equals 0. So
yeah.
Okay. I didn't collect opens, but but that was these were all the questions I had for today. I think made some progress. We'll circle back and see what other topics people have.
Can we go back to force DMA encrypted?
Yeah.
So my current version of force DMA encrypted is false if device is accepted. And you said you have a patch, or you can think of a patch. Can you just post it or?
Yeah, I was gonna post it. Yeah, so I'll post it and put it in the SIG. But I think we're all in agreement that force DMA unencrypted should just have a. I think the way you have it works for everybody. Well, actually, force DMA encrypted is architecture specific, so it doesn't. So the ARM will have its own thing. But I think Intel and AMD are the same. We force it unencrypted if the device is not. We don't force it unencrypted if the device is accepted.
That's true with even ARM.
Yeah. So I think we're all the same.
We don't force if device is okay. About software TLB, we don't force it if device is I don't force it if device is accepted.
Right.
You do the same, right?
Yeah, we want the same.
And fees to DMA, if device is accepted, I say fees to DMA unencrypted, so I clear the C bit. And you want to keep it?
Oh no, I want to. It doesn't matter if you keep it or not because but we need to move that because FISA DMA is in a common location. You need to move that x86 thing out of the way so it doesn't.
So we may end up doing what I'm doing now, but it better be x86.
Yeah. So this one
because it breaks ARM.
Yep.
Okay. Yes, we need to start posting this stuff at some point.
Yeah. I mean, like, if you want, like, I think I understand. I think I can, because I was going to include this force DMA encrypted. I can also include this change what I think it is. You can review that too if you want. I can, whatever you want to do. But I'm okay to pull that in, make an attempt.
I can shuffle and post.
Okay.
Another thing had MMIO plus GMMFD, which you must have a patch for that, right? In Yellow 3 internally.
we have one, but I don't think he hasn't rebased it in a while.
Right. And Anish doesn't need it. So I can post mine. And
Anish doesn't need it. I thought we all need GMMFD and IOFD.
No.
So there is no in-place conversion, right? So the guest mem patches are freed, we punch hole and things like that. So there is no need for gmem to notify IOMMUFD.
So Anish's shared pages are just accessible using legacy interface by mapping from user space addresses.
Yeah.
And we cannot do this on AMD. That's the difference. So I can stop harassing Anish. I can just start posting my stuff. And the thing we need to figure out is that when we get PFN from GMMFD and map it in IOMMUFD, then we need some notification mechanism from KVM to tell IOMMUFD that this mapping is no more valid. And
yeah, so there was this community discussion at LPC to kind of do this, right? I forgot the name, like the GMM guys were planning to implement this, isn't it? Because Intel also had this need for the same BFN not appearing in both shared and secure and non-secure kind of view of IMMU, and otherwise it will check stop or something like that. And he was kind of insisting on GMM to kind of have a callback to IMMUFD, right? At the last plumbers.
well, I was not there. I don't know.
I can pull up the.
If there was a talk about callback, I would love to see a patch.
Yeah, he pinged me to understand why ARM doesn't need that. I can kind of loop you in. Probably they already have a patch, or you can discuss what you have and then.
And ARM decides to remap page on conversion from QEMU, right?
Yes.
Okay. I guess you cannot do this with this kind of notification from GMMFD. Or maybe you can.
Was that insight like it's just a difference in the KVM? So KVM unmaps without needing. So you only need the. Do you need a KVM back to IRMFD callback notification?
Well, it's kind of KVM which gives me physical page number, but right. KVM calls into GMMFD right away for that. That's then when you remove pages from GMMFD, and that would be only what? Truncate? Or on every conversion? You want
I think while converting via GMM interface, whatever that is, either on the fault side on an mmap or I think GMM has this in-place conversion. That conversion should have hook into IOMMUFD. That's what the discussion was.
Right.
Well, I think this is only needed when there is in-place conversion. I posted the name of the person working on it. I mean,
also, when you remove memory from the guest, then you need to unmap a bunch from IOMMU.
Yeah.
And when you add memory to the guest, you need to do the same. That probably can be handled by QEMU.
Yeah.
Okay. If you find any links, and post would be great.
Yeah.
But ARM is using guest MMFD.
ARM is using guest MMFD only for private pages. We don't have in-place conversion, so we don't need any of this.
We don't have in-place conversion. So, I thought, but doesn't that won't you need in-place conversion and that support when we go to huge pages?
That part I haven't actually looked at or thought about, but at this point we are not using. Why would you need? Oh, because the huge TLB need to be remained as a huge TLB itself.
Something like this. Yeah.
I'll
Yeah,
have to
but
think
maybe
about it.
okay, but again, the question is, can we skip needing this callback right now if the first version of what we're doing is 4K only?
Yeah, I mean, even in case of huge pages, right? Our IOMMU also doesn't have a problem if I have the same PFN appearing in both private and shared part of the IOMMU. So
Oh,
it's
I
okay to
see.
leave it there. You just need to make sure nobody's going to touch it. Uh, like even in case of huge pages, the we will get proper fault back via GPC. Like it's not like I think that was the discussion we were having at LPC. Why would one need this? If why can't we
Okay.
leave it to the IOMMU table itself? Why would one need to take out from whatever is the view of IOMMU? I think for the AMD, the problem is the DMA handle is the same, whether it is private or shared, and hence uh, whatever CBT you are setting in DMA handle or in the IOMMU, it needs to flip. It need to go and change it during transition. So they need a hook.
Well, at this
We have
point, no, nothing needs to be done to DMA because the entire guest is treated as encrypted or non-encrypted for this specific device. So there is no pure page flip.
yeah, I got. Yeah.
The only reason I need it, maybe, if I mess with guest from add and remove actual physical guest memory.
Oh, memory hot plug?
I think so. Otherwise, it's just, I don't need it, so I don't have it. And Jason says I need one. And I need to post it separately from the rest of like 40 patches.
So when you do a guest memory hot plug, why are you going by a guest MMFD then? Why do you need all these things?
No, I don't think I need for memory hot plug. For memory hot unplug, I probably do. Something needs to tell IMMU that memory is gone and mapping should be removed. And it can be KVM, which actually gave all this PFN
Oh,
to
okay.
IMMUFD.
So
Or KMU.
it's not really IMMU, GMMFD telling IMMFD. You want KVM telling IMMFD, which should already exist, isn't it? We have it only telling I mean, why is this not a need for non-confidential guest?
Because I think KMU takes care of it.
And you can't do it when T equal to 1 or CC or confidential guest?
Should be able to. And probably
Is this,
we don't need the mechanism then from KVM to IMMUFD.
Yeah, I thought the need was while conversion, but if you don't have a per page hinting of private shared in the IOMMU table, you probably don't need it.
No,
But
Jason's point was that for how long is that translation alive and that pinning of PFN? It's about the lifetime of pinned private memory. Okay, I'll just repost patch and see.
Okay.
Lifetime of pinned. So, I mean, so in that case, if that's the case, then ARM would need it if we're trying to make it the consistent model of when KVM is done with it, IMUFT gets a notification. So maybe just trying to close an existing hole between KVM and IMUFT, or
I think we can wait for the patch and then see what exactly are we looking at. And then
Because right now when we map user space addresses, then we pin memory behind those addresses. It doesn't go away. And with
Right.
MMFD, we don't pin anything.
Right.
So
Yeah, I think
it's there, but like maybe it's
not actually there. It's not there.
And then the maybe the ask was let KVM people see it and talk loud if their pinning is like really good and we don't need to care about it and it's all good as it is.
I mean, the VMM I'm using is not really supporting the memory unplug, but I thought all these things would be plugged into GMM punch hole, and then like the unplug would come to QEMU would know that there is a GMM mem slot, and then the GMM mem slot will go and punch hole to free the backing PFNs of that GMM so that the things are kind of unplugged. So that punch hole will anyway go and remove the pin and then unmap things and things like that, right? That's what I was expecting, but then we could probably look at the patch and see what am I missing.
Right. Good.
Okay.
Seem to be on the same page then.
Okay.
I had another question about pages. I really want to get rid of 4K shared pages. I want to keep sharing a 2 megabyte boundary. And then Mike Roth pointed me at Anish's patches, where Anish is forcing alignment to 64K.
Yeah.
And on ARM, those 64K pages, they're like an NPT, and they are still considered small pages, like PowerPC 64K pages, right? They're not huge pages, like 2 meg pages. They're still leaps.
Yeah. So what I'm trying to do is slightly different. I am trying to support a confidential guest of page size 4K on a host of page size 64K. So in order for the sharing to work, we have to make sure that the guest shared at aligned to size and address a 64 granule, because the host is using host page table which is configured with 64K page size, and the guest is using guest page table which is configured with 4K, right? So we just needs to have an ability to make sure both of them are aligned, so that things go smooth, right?
So when you say host, it's like stage 2 table, what we call NPT?
Not really. It is QEMU's access in what granularity?
So it's the shared memory. Anything that's shared between guest and host must be 64K aligned and a multiple of 64K. So that they don't have issues.
Okay. Have you thought of making it 2 meg?
Yeah, I think we can look at making it 2 meg. I think whatever patches I posted can do. So the basic way I implement this is there is actually a call from the guest asking the VMM or the hypervisor what is the shareability kind of like attributes, right? So if I return 2M, then everything would be aligned to 2M. And if the host intend to share things at 2M granularity, it should work. It's not really
See, the reason I'm asking every time I bring up this RMP thing, which works at 4K and 2 meg boundary. Jason asks, why do you share 4K only? Like share 2 meg or better, like 1 gig. Why do you even bother with this piece meshing and all that stuff? And he didn't say the same to you.
No. So here is the trick, right? Here is the trick. Now, all this thing I'm talking about is from a QEMU page table and the guest page table point of view. We do have stage 2, which is managed by firmware, and the firmware has its own flexibility of creating whatever grand mapping it wants. So if it finds a contiguous range of 2M, it can fold the entire thing to 2M, right? The stage 2, the firmware can fold it to 2M. So it's kind of independent of what we do in KVM, because firmware it's the stage.
it's going to be still 2 meg leaf if there is a mix of shared and private.
If everything is aligned correctly, right? So the goal is to make sure that we tell the firmware that, okay, this is 2M aligned and the private is free. Then yes, the stage 2, the firmware can try to put it at 2M. Like,
No, wait. Like, as of today, you don't enforce 2 meg for shared memory, right? You only enforce
no,
64K. And if you have private and shared in the same 2 megabyte region, you will not have 2 megabyte leaf in NPT.
Yeah.
You'll have a bunch of 4Ks, right?
Yeah.
Or 64Ks. What would be the page size if the host is 64K?
So there are a few things, right? The host is 64K. The stage 2 can still be 4K, or the stage 2 can be 64K, or the stage 2 can be any. I mean, the granule size, what we call it as a granule size for the stage 2, it can be what the firmware decides depending on the contiguity of the physical memory and things like that.
Is there a
So
big reason for it to be 4K?
The plan is that when host page size is 64K, we need a realm also to be at 64K. The confidential VM stage 2 would also be at 64K. It doesn't make much sense to stay
Yes,
at 4K.
exactly. It doesn't make much sense to do it at 4K grand size, but it will also work. What I'm trying to say is the entire thing is so independent that we can make these combinations work. The idea of the firmware side is to be generic enough. Now, why would you want to be 4K? We don't want to, because we are anyway aligning things to 64K. So the firmware will anyway align to 64K.
Yeah.
Good. Makes sense. Thank you.
But in terms of the staging tree and the, it's interesting that I thought Jason was also on board with the idea that we're doing 4K only for now, just to get things started. That the huge page trying to do large RMU mappings for confidential devices is on the roadmap, and not the first thing we're trying to do. You're getting the opposite feedback?
No. They're trying to do 4K for now. Yes.
Okay.
But we still have this 2 meg page thingy going on.
Okay, yeah.
So we have to talk about it at some point.
Yeah,
the sooner the better.
We can't kick that can down the road. Okay, but just making sure we're on the same page. Yeah, no, that we do have to keep talking about it. So this brings up my last thing, and before we
The
wrap
other
up,
thing that I'm stuck on is DMA buff, right? I mean, I need that to kind of complete the life cycle of the guest. Do we know? Like, when I was asking Yulin if we could share it or post it so that we could start working on integrating it into the series architecture.
That was what he was working on right before Lunar New Year.
Okay. I mean, if we can host it as an independent branch also, that would be nice, because it would take architectures to catch up. I think Alexis already pulled some version of DMA buff into his patch series. I have been avoiding DMA buff.
I actually want the fixed version, which takes into account MSIX.
Okay. I have been avoiding DMA buff completely, but I think we are at a point where we need that to kind of make sure the life cycle is correct.
I mean, I thought the bulk of the hard work was done with the VFIO to DMA buff connection.
Yeah.
So we also just go with Alexi's version and pull that into the staging tree. So.
Oh, okay. So if I just didn't want to try to do one myself, and then we have like 3 different versions kind of a thing. That's what I was waiting for, and I was looking at something else. But then if we all are taking what Alexi have in its patch series, then I can pull that too. But if there is a different version, I mean, what I'm requesting is if we can host it as a branch in somewhere.
Yes. Let me see if I can pull it in. Like, Alexi, could you? Maybe we're at the top of the hour, but can you post that on Discord, your current version? I think we probably just go with that for now, and off we go.
It's not mine; it's Elon's.
Okay, post it. Post what you're using, and we'll polish it and and make that. I'll pull that into a staging branch.
I'll do right after the call.
Okay, but you're using the old version of eLoons, like the one that did the PFN export, not the one that's been rebased on the new DMA buff capability. Well, I'll take a look at what you posted. Maybe I can answer your question. Okay.
It's about 5-6 months old, I think.
Okay.
And it's not the first version.
Okay. I'll take a look and put it in the staging tree.
When is Yelon back?
Next
His professional opinion about these patches.
Yeah, should be
whether
next
we
week.
want newer stuff or not.
Yeah.
In order to get the link, I have to authenticate in GitHub, and then I need to do this two-factor authentication because it's AMD account.
Okay. Well, that's all I had.
Do we have a rebased tree available, Dan? Like you were working on that, like.
I was working on that, and now that I got these kind of questions answered about the SPDM tree,
Okay.
and the auto pro policy, I think I'm ready now to post a new version, and the fix the fizz to DMA thing and the force DMA unencrypted. I think with all those resolved, I can post a new version of that phase. We can go from there. Cool. Otherwise, yeah, I will talk to you all in a couple weeks.
Thank you.
Good.
Yep. Ping me on Discord if you got any other questions. We'll see you.
Oh, definitely will.
Okay. Hey, talk to you later. Bye.
Thank you. Bye.
Bye. Yes.